Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the synthesis of pyridine, and one of the method which is the best method for the synthesis of the pyridine, which is written over here, from acetylene, that is a mixture of acetylene and hydrogen cyanide is passed through red hot tube, gives pyridine with high yield is obtained. So this is one of the method we were described in our previous lecture. Along with this, what would be the structure of pyridine, why what are the properties of the pyridine, why pyridine act as an base, or as compared to the pyrrole, pyridine is more basic in nature than the pyrrole. That kind of the discussion we were described in our previous lectures. So today what we are going to describe, what we are going to discuss, the remaining method for the synthesis of pyridine. Let's begin with the second one. First one is already written over here, from acetylene. Acetylene is the starting material. Mixture of the acetylene and the hydrogen cyanide is passed through red hot tube, gives pyridine. Look at the representation of that reaction, how it can carried out and how we are getting as a product that is represented over here. Now let's move on to the next one, that is the second method for the synthesis of pyridine. So let's begin with the second method, from that we can prepare the pyridine, synthesis of pyridine we are talking. So second method for the synthesis of the pyridine from acrolein. Second one is from acrolein. It is very important once again, from acrolein. As we know that acrolein is one of the compound which is obtained by aldol condensation. If you remember your T.Y.B.Sc days, there you might have heard, might have learned that reaction, aldol condensation reaction, and in that there is a cross aldol condensation reaction, and in cross aldol condensation reaction, as we know that there is a criteria, one of the carbonyl group must contain alpha hydrogen atom, then and then reaction takes place in presence of base, and two molecules condensed together generally produce the beta hydroxyaldehyde or aldol, and which further strongly heated produce the alpha beta unsaturated compound, and that is the stable compound we form. And there is a acrolein is one of the starting material which can be easily prepared by using very famous named reaction, which is a aldol reaction. Why aldol reaction is the most important? Because there is a formation of the new carbon-carbon bonds. Whenever there is a carbon-carbon new bonds are formed, that named reaction or that reaction are very important as far as synthetic organic chemistry point of view is concerned, because you are developing a new methodology for the synthesis of that new compounds, and that's why it has very great important or in the synthesis part from acrolein. How one can prepare pyridine in the laboratory, that we are talking, a mixture of acrolein and ammonia on heating cyclases to form 3-methyl pyridine. So that is one of the simplest compound here. A mixture of a mixture of acrolein and a mixture of acrolein and ammonia, a mixture of acrolein and ammonia on heating, a mixture of acrolein and ammonia on heating gives 3-methyl pyridine. It is one of the simplest and the high yielding product obtained so a mixture of acrolein and ammonia on heating cyclizes to give to form 3-methyl. Here let me clear this sentence once again. A mixture of acrolein and ammonia on heating cyclizes to form 3-methyl which is a product obtained by doing these things. Let's see here. Starting material, they have taken acrolein, a mixture of acrolein and ammonia on heating cyclizes to form 3-methyl pyridine. So simple reaction it is. Let's take down the starting material. This one CH2 double bond CH, then C double bond OH. It is known as acrolein, which was taken 2 equivalent CH2 double bond CH, C double bond OH. This is the common name of this compound is a acrolein, which can be obtained by using aldol condensation, and now it will be treated with ammonia NH3, and it will be treated with once again in shield tube. The resulting compound obtained will be, is already name is written here, so you can say here double bond, here double bond, and here double bond. This is a carbon, this is a heteroatom nitrogen. Numbering start from it either left hand side or the right hand side, but when it attached at 3 position, look at 1, 2, 3, at 3 position methyl group is there, and therefore it is called as 3-methyl pyridine. That would be the product obtained in this particular synthesis from acrolein, a mixture of acrolein and ammonia on heating cyclizes to form 3-methyl pyridine. Look at the structure of acrolein is this one, CH2 double bond CH, C double bond OH. 2 moles of that acrolein was taken, treated with ammonia, heated in the tube, and yielding high yielding product which is 3-methyl pyridine. So that is the compound which we are getting here with high yield. So this is a second method for the preparation of pyridine. Now let us move on to the next method, which is utilized or which is used for the synthesis of pyridine. Let's see here another method, which is a third method. And here third method, from this whatever we have prepared in earlier, the common name of this 3-pyridine, this one we have got here. How we are getting this compound? Let me revise once again this structure. 2 moles of CH2 double bond CH, then C double bond OH, be treated with ammonia, heat it in a tube. The resulting compound form is known as, this is the starting material is taken as a acrolein, and this is ammonia, as we know that ammonia, and this one we are getting as a 3-methyl pyridine, and the common pyridine, this is a 3-methyl pyridine, and common name of this compound is a procholine. The common name of this compound is a picoline, not this one, that is a picoline. That is a common name of this compound. 3-methyl pyridine is nothing but as a picoline is a common name, and by using as a picoline, third method, we can prepare the pyridine, and picoline may be present in a various isomer. 3 isomers are possible. Isomer means what? Having same molecular formula but different structures are known as a isomer. So picoline also has a 3 isomers, then 2-methyl, 3-methyl pyridine, 2-methyl pyridine, 3-methyl pyridine, or 4-methyl pyridine, having the same molecular formula but different structures. So that type of the compounds are known as isomers. The methyl group, when it is present at 2 position, it has different physical properties as well as chemical properties. If methyl group are present at 3 position, that picoline has a different physical properties as well as chemical properties. Similarly, methyl group which is present at 4th position, that is a 4-methyl pyridine or picoline, which also has different physical properties as well as chemical properties. Now starting from third method will be from picoline, and just now we have seen there are the 3 different isomers are possible: 2-methyl pyridine, 3-methyl pyridine, or 4-methyl pyridine. These are the 3 isomers of picoline. So picoline is a methyl pyridine. Picoline is a methyl pyridine. Picoline is a methyl pyridine. Picoline is a methyl pyridine, and these are 3 isomers of picoline. There are 3 isomers. There are 3 isomers. There are 3 isomers of 3. There are 3 isomers of picoline, 2, 3, and 4. 2, 3, and 4. When picoline, when picoline, any one isomer when picoline any one isomer is oxidized by KMnO4, that is potassium permanganate, KMnO4, that is a potassium permanganate, it gives what it gives? It gives respective picoline acid. It gives respective picoline acid which on decarboxylation gives pyridine. That is another method for the preparation of pyridine. Look at once again, we are synthesizing the pyridine from picoline. Picoline is a starting material. Look at here, picoline is a methyl pyridine. There are 3 isomers of picoline, 2, 3 and 4. When picoline, any one isomer is oxidized by potassium permanganate, it gives respective picoline acid which on decarboxylation gives pyridine. Let's see the starting material. Here I am taking the starting material is a picoline, one of the isomer which is at 2 position methyl pyridine. I am taking here 2 methyl pyridine, and which is commonly known as picoline. And when it is treated with, or when this compound oxidized by potassium permanganate KMnO4, as we know that it is a strong oxidizing reagent, what it does, it converts the methylene group into carboxylic group, that is C double bond OH, and which is known as picoline acid, or you can call it as a pyridine to pyridine carboxylic acid. Pyridine to carboxylic acid, you can call it as a pyridine to carboxylic acid to carboxylic acid. And this 2-carboxylic acid, when further treated with calcium oxide, which is the reagent known for decarboxylation, minus here hit it minus CO2, carbon dioxide is easily evolved, and the resulting compound octane will be the pyridine. So this is a third method for the synthesis of pyridine. How one can get the pyridine? That is one of the simplest method to obtain the pyridine from picoline. Once again, remember picoline which we have obtained from acrolein. on heating with a mixture of acrolein and ammonia, heating with resulting compound obtained will be picoline, generally 3-methylpyridine, and that picoline, starting from that picoline, we can get the pyridine in this way. Picoline is a methylpyridine. There are 3 isomers are picoline, 2, 3 and 4. See this structure, 3 isomers I am representing here. You can see here 2-methylpyridine. Another structure you can see here clearly. This would be the 3-methylpyridine and this would be the 4-methylpyridine. If you observe these 3 structures carefully, all having same molecular formula but different structures, and the relationship between these compounds, they are known as isomers of each other, but their properties are very, very different from each other, and that's why that one of the procoline, when picoline, any one isomer is oxidized by potassium permanganate, it gives respective picoline acid, which on decarboxylation gives desired product, and which is a pyridine obtained here. So that is one of the compound, and in this way we have learned 3 methods from. There are 3 different methods for the synthesis of pyridine. One can prepare pyridine by using those above procedures. Now moving on to the next point. What is the next point we are going to discuss? That is the reactions of pyridine. Whatever the reactions we have seen, we have studied earlier in our previous lectures regarding 5-membered aromatic heterocyclic compound and 3 commonly known heterocyclic compound. 5-membered heterocyclic compounds are furan, pyrrole and the thiophene, and there are different methods for the synthesis of that 5-membered compound, and the starting material is commonly used as acetonyl acetone, means 1,4-diketone, and treating with the different reagent, or we can say catalyst reagent along with the different catalysts, and the resulting compound obtained will be the relative 5-membered compounds such as furan, pyrrole and the thiophene. And after synthesizing those 5-membered ring in the laboratories, we have also discussed the different commonly known electrophilic, they undergoes electrophilic substitution reaction mainly at 2 positions. Why they undergoes electrophilic substitution reaction mainly at 2 positions? And we elaborated that point by considering the resonating structures we actually drawn the resonating structure of that general 5-membered ring. From that general reaction, what we found, other than a heteroatom, all these 4 positions carrying partial negative charge, and from that we infer that the electrophilic substitution can occur at both the position alpha as well as beta, or 1, 2 and 3 position. But when we actually drawn the resonating structure by attacking electrophile at 2 position and electrophile attack at 3 position, what we found, when the electrophile attack at 3 position, we found that 3 resonating structures, but when the attack of electrophile at 2 position, we found that only 2 resonating structure. In addition to that, one of the carbon-carbon double bond is not involved in the delocalization, and from that we infer that theoretically as well as practically the all 5-membered rings such as furan, pyrrole and the thiophene undergoes electrophilic substitution reaction at 2 position, mainly at 2 position, exclusively at 2 position. That kind of the discussion we already, as well as the commonly known reactions such as sulfonation, Friedel-Crafts alkylation, diisocoupling reaction, Rimmer-Tymon reaction, hydrogenation reaction. Same reaction we are going to discuss with pyridine, and therefore that is the important part, which is the reaction of pyridine, and that reaction of pyridine we will discuss in our next lecture. Still have a nice day. Thank you.